Good morning, students. This lesson is of class 9th for the subject of physics. Topic for today is Pascal's law and its application. Now, students, first of all, let us see what is Pascal's law. According to Pascal's law, the pressure exerted anywhere in a confined liquid, Now, what do we mean by confined liquid? Confined means restricted in a particular area, is transmitted equally and undiminished in all directions throughout the liquid. For this, you can do an activity. You can take a rubber ball and pierce some holes in the circumference of the ball as shown in figure 1, and then dip this ball in a water for some time, and after certain duration of time, take the rubber ball outside the water and compress it gently as shown in figure 2. You will observe that water will rush out from all the holes, and this water rushing out will be of equal pressure. Now children, before starting further, I want to show you this experiment also. So kindly have a look. Now again, this is Blaise Pascal, the name of a physicist who gave this law. According to the Pascal law, it states that when pressure is applied to a point in a confined liquid or a fluid, it is transmitted equally in all directions. This is the example of a ball which I was talking to you. You have made certain holes in this football, and when you put a little pressure using a piston, the water comes out of the piston, and when the water is flowing out, it is flowing with same pressure from every side. Again, have a look. See, the pressure of water coming out is equal in all the holes. So this was our Pascal's statement. So this is one more activity which can be done. You can take a vessel, a rubber vessel having 4 openings. You can put fluid inside this container, this vessel, and then you can press this vessel from any 4 of the pistons. See what happens. Now children, what is this? This is a rubber vessel. Inside it we have poured certain water in it. Now these are pistons A, B, C, D, and all are unleakable. They are not leaking from any part, and all these pistons, what we are doing, all pistons are tied here, and now I will be compressing it from one end only, that is piston P at point A, the first piston at the top. See, if I am compressing, what happens? Let us see what happens. Compress, see what happens. Now children, when we compress here, this is the liquid, water inside it. And when I press this whole thing, equal pressure is exerted at all the 3 pistons. Okay, just have a look. When I press the uppermost part, see, with the same pressure which I have exerted up is exerted on all the vessels, knobs, all the ends. So this proves our Pascal law that liquid confined, now this liquid was confined in this vessel and this restricted in certain area, this confined liquid is spreading the pressure undiminished in all the directions, and it is giving same pressure at each and every point of the vessel. Children, similarly, principle of hydraulic machine, any hydraulic machine is the principle of a hydraulic machine is that a small force applied on a piston. We are applying a very small force on one of the piston such that a higher force is experienced on the other side. Why so? Now children, in this case also, if a small force is applied on a smaller piston, that force is transmitted to produce a large force on the bigger piston. So here is an example given to you. This is, children, this is a U-shaped vessel. A U-shaped vessel of unequal area. On the left side, the area is small a, that represents small area, while on the right side, the right arm is having huge area. So I'm taking that area as capital A. You can see this in figure number 4 also. Capital A stands for bigger area, while small a stands for lower area at point P. These two arms of the vessel are in different areas. Now children, I'll be pressing the smallest piston with a very less force. And according to Pascal's law, this force will get transmitted to the other part of the arm, and now this value of the force would have enlarged. It would have increased such that you can even lift a heavy vehicle placed on the bigger piston. So for this children, there is an explanation of figure 4 given to you in the PDF page number 2. And here in page number 3, I have explained this whole concept using certain values. So let us learn from the values first. Children, I have taken small area as 1 meter square and the larger area as 100 meter square. So according to the Pascal's law, pressure at both the ends, that was pressure at point P, would have been equal to pressure at point Q. That was bigger area. So this formula of pressure at point P can be written as small f upon A is equal to capital F upon capital A. We have to find capital F. How much force is given? So let us say that I am applying only 50 Newton. So force applied is 50 Newton. Area of left arm was 1 and area of right arm was 100. So children, when I have applied only 50 Newton force, after calculation you will see that on applying 50 Newton force, a 5000 Newton force can be observed. So children, by applying just a 5 Newton force, that means 5 kg of mass, if we keep, we are getting 5000 Newton force, which means we can lift a mass of 50 kg. So that is its main importance, that just by applying very less force, we can have a result of higher force. Even this process is known as force multiplication. Why force multiplication? Because here we are multiplying the force. The force must have multiplied with itself. So children, this is also known as force multiplication, and this process is also known as force multiplication, and there are few examples of hydraulic machine. For example, hydraulic lift, brakes, hydraulic press, and the use of hydraulic pressure is for pressing the cotton bales and goods like quilts, books, etc. For extracting the juice from sugarcane or sugar beet, for squeezing oil out of seeds and cotton seeds, and for engraving monograms on goods. So let us see this also. So children, here you can see there are two pistons, a bigger piston and a smaller piston. See, and this is a U-shaped container in which you are placed certain liquid inside it, and this U-tube container is having two different areas. Area A is less than area B, and on area A, piston A, I have to apply very less force to get a major effect or a major force at point B. So let's see how the things happen. So children, whenever, see, now what is happening here? If we press the liquid downward, I have put a certain weight at the top of A. So I'm putting pressure at point A such that at point B, the equal pressure is transmitted and this surface, this piston rises in an upward direction. So this was the basic concept of Pascal's law. So children, now let us come to the numerical part of the Pascal's law. And it is a very easy numerical. So children, question number 1 is, the area of piston in a hydraulic machine are 5 and 625 centimeters square. What force on the smaller piston will support a load of 1250 Newton on the larger piston? Children, smaller piston. Area of smaller piston was 5 centimeters square and bigger piston is 625 centimeters square. And we have to find force at smaller piston. So children, put the values, and there is no need to do conversion of centimeter square into meter square. Why? Because when we are having equal units, same units in division, the units gets cancelled out. So children, we can cancel this centimeter square with centimeter square, and then after doing further calculation, you can find the value of small f, which comes out to be 10 Newton. So children, now you all are required to take a break for 5 minutes and do numerical number 8 given on page number 94 in your physics notebook. And after solving the numerical, you can resume the lesson for understanding other numericals also. So I hope you have done numerical number 8. So now students, let us see question number 2. The diameter of neck and bottom of a bottle are 2 centimeter and 10 centimeter respectively. So the neck is less broader, or you can say neck is more narrower as compared to the bottom of the bottle. So the bottle is completely filled with oil. If the cork in the neck, here, it is pressed with the force of 1.2 kgf, what force is exerted on the bottom of the bottle? So children, for reference, you can see figure number 1. And here, diameter of the neck is 2 centimeter. So if diameter is 2, radius is half of diameter, that comes out to be 1 centimeter. And therefore, smaller area. Now this neck is circle in nature. So we can take area as pi r square. So let's take area to be pi r square, where r is 1. So area comes out to be pi centimeter square. This is small area. That is area of the neck. While if I want to find area of the bottom, then first of all find the radius of the bottom lower part, that is 5 centimeter, and then using pi r square, our answer comes out to be 25 pi centimeter square. So children, further using Pascal's law, that is pressure at the neck of the bottle is equal to pressure at the bottom of the bottle. So putting the pressure as force upon area and then substituting the values of small f, small a and capital A already calculated above, then we can find the value of capital F, which comes out to be 30 kilogram force. So similarly, now you can do question number 3 given in the PDF. Here, pressure exerted by the water will be bringing, there is mercury. First of all, see students, this is mercury. And above the mercury, you have put little water on the left side of the arm of the surface of the vessel. So this water is exerting pressure on mercury in a downward direction such that pressure exerted by water at point A will be equal to pressure experienced by mercury at point B. So here, instead of writing force upon area, the water is exerting pressure at a certain depth. So it is a formula of pressure due to liquid column, and here therefore I'll be using the formula of H rho G, where density of water is 1000 kg per meter cube and density of mercury is 13.6 multiplied by 1000 kg per meter cube. So in the similar manner, you can do fourth question that is totally same as question number 3. And question number 5th is again, you are having two different areas, small f and capital F. So children, question number 5th, you have to find small f, where we will be using Pascal's law, that is f by a is equal to capital F by a. Small f we need to find. Small a is given in the question. Capital F is also given 400 kgf and capital A is also 4 meter square. So you substitute the value to find the answer and small force will come out to be 1 kilogram force. So students, kindly go through the solved numerical problems and read the question carefully and observe the given figures also. And your homework is try to solve numerical number 8, 9, 12, 13 and 14 given on page number 94 in your physics textbook. So students, with this, I come to an end of this interactive session. Thank you and have a nice day.